measurement of smaller distance. Screw gauge. The screw gauge is an instrument used for measuring accurately the dimensions of object up to a maximum of about 50 mm. The principle of the instrument is the magnification of linear motion using the circular motion of a screw gauge. Least count is equal to pitch scale by total number of head scale division. So in pitch scale, the distance between 0 and arrow is equal to 1 mm. Total number of head scale divisions is equal to 100. So least count is equal to 1 mm by 100. That is equal to 0.01 mm. No error. Pitch scale 0 line is coincide with head scale 0 line. It means no error. Positive error. If head scale 0 line is below the pitch scale 0 line, it means positive error. Negative error. If head scale 0 line is above the pitch scale 0 line, it means negative error. Screw gauge reading. A model reading. Pitch scale reading 6 mm. H scale reading 40 divisions. So the reading is equal to PSR plus HSC into LC. PSR is equal to pitch scale reading. HC is equal to H scale correction reading. LC means least count 6 mm plus 40 into 0.01 mm is equal to 6.40 mm. Least count of Vernier caliper. Vernier caliper. A Vernier caliper is a versatile instrument for measuring the dimensions of an object, namely diameter of a hole or a depth of a hole. The least count of the Vernier caliper is 0.1 mm. Least count is equal to 1 main scale division by total Vernier scale divisions is equal to 1 mm by 10 is equal to 0.1 mm or 0.01 centimeter. No error. Main scale 0 line is coincide with Vernier scale 0 line. It means no error. Positive error. If main scale 0 line is after the Vernier scale 0 line, it means positive error. Negative error. If main scale 0 line is before the Vernier scale 0 line, it means negative error. Vernier scale reading. MSR. If Vernier scale 0 line is coincide with the main scale reading is called main scale reading. VSC. In Vernier scale there are 10 divisions. If any one of the line is coincide with main scale line is called Vernier scale coincidence. A model reading. MSR is equal to 2.2 cm. VSC is equal to 4 divisions. Reading is equal to 2.2 cm plus 4 into 0.01 cm. That is equal to 2.24 cm. That 0.01 cm is least count. For measuring larger distance, such as the height of a tree, distance of the moon, or a planet from the earth, some special methods are adopted. Triangulations method, Parallax method, and radar method are used to determine very large distance. Triangulation method for the height of an accessible object. Let A B is equal to H be the height of the tree or tower to be measured. Let C be the point of observation at a distance x from B. From right-angled triangle ABC, triangle ABC is equal to theta. Tan theta is equal to AB by BC is equal to H by X. So height H is equal to X tan theta. Knowing the distance X, the height H can be determined. From a point on the ground, the top of a tree is seen to have an angle of evaluation 60 degree. The distance between the tree and a point is 50 meter. Calculate the height of the tree. Solution. Angle theta is equal to 60 degree. The distance between the tree and a point x is equal to 50 meter. Calculate the height of the tree. H is equal to x tan theta. So x is equal to 50, theta is equal to 60 degree. So tan 60 degree is equal to 1.732. So H is equal to 66.6 meter. Parallax method. The shift in the position of an object when viewed with two eyes, keeping one eye closed at a time, is known as parallax. An observer is specified by the position O. The observer is holding a pen before him against the background of a wall. When the pen is looked at first by our left eye L and then by our right eye R, the position of a pen changes with respect to the background of the wall. The shift in the position of an object when viewed with two eyes, keeping one eye closed at a time, is known as parallax. The distance between the left eye L and the right eye R in this cases of the basis. Angle LOR is called the parallax angle or parallatic angle. Taking LR as an arc of the length B and the radius LO is equal to RO is equal to X, we get theta is equal to B by X. B basic X unknown distance. Knowing B and measuring theta, we can calculate X. Determination of distance of moon from Earth. If theta is measured in radians, then theta is equal to AB by AM. AM is approximately MC. Theta is equal to AB by MC. MC is equal to AB by theta. Knowing the value of AB and theta, we can calculate the distance MC of moon from the Earth. Radar method. The word radar stands for radio detection and ranging. Speed is equal to distance travelled by time. Distance is equal to speed of radio waves into time. So 2D is equal to V into T. D is equal to V into T by 2. Example 1.3. The radar signal is burned towards a planet and its echo is received 7 minutes later. If the distance between the planet and the Earth is 6.3 into 10 power 10 meter, calculate the speed of the signal. So, the given data, the distance of the planet from the Earth D is equal to 6.3 into 10 power 10 meter. So, time T is equal to 7 into 60 seconds. So, the speed of signal V is equal to 2D by T. So, 2 into 6.3 into 10 power 10 by 7 into 60, that is equal to 3 into 10 power 8 meter second power minus 1. Table 1.5. The range and order of lengths. The distance of moon from the earth is equal to 10 power 8 meter. Diameter of red blood cell is equal to 10 power minus 5 meter. Astronomical unit. Light year and parallax second. 1 light year is equal to 365 into 24 into 60 into 60 into 3 into 10 power 8 meter. So, 1 light year is equal to 9.467 into 10 power 15 meter. 1 parallax second is equal to 3.08 into 10 power 16 by 9.467 into 10 power 15 meter. So, 1 parallax second is equal to 3.26 light year. Measurement of the mass. Mass of a body is defined as the quantity of matter contained in a body. The SI unit of mass is kilogram or kg. The mass of an object is determined in kilograms using a common balance, like the one used in a grocery shop. For measuring larger masses like that of planets, stars, etc., we make use of gravitational methods. For measurement of small masses of atomic or subatomic particles, etc., we make use of a mass of spectrograph. Some of the weighing balance commonly used are common balance, spring balance, electronic balance, etc. Table 1.6 Range of masses. Mosquito mass 10 power minus 5 kg. Sun mass 10 power 30 kg. Measurement of time intervals. Some of the clocks developed later are electronic oscillators, solar clock, quartz crystal clock, atomic clock, decay of elementary particles, radioactive dating, etc. Table 1.7 Order of the time intervals. Wing of an eye, time interval 10 power minus 1 second. Age of universe, time interval 10 power 17 second.